Welcome to this class. This is our first class for our first session to do examples on implicit differentiation. So we start by appetizers. So the question is to differentiate with respect to x power 3, y power 3, x plus 3y, y squared, x cubed plus y cubed, sine x, y. So let's even add another question here, g. Say e raised power x, y squared. And then h, let's add h, say tan of x, y squared. So let's see how we will carry out this. So solution. So part A is x power 3. So x power 3, we differentiate with respect to x means you supply d dx to this term. So d dx of this term, this will be 3 by power rule x squared. So that's the answer to part A. Part B, we have y power 3. So to differentiate with respect to x means you supply d dx to this term. Now what happens here, y is assumed to be a differentiable function of x. So you'll do the normal power rule, which will be 3y squared. But because y is assumed to be a differentiable function of x, then you attach dy dx to that value. So that will be the answer to part B. C, we have x plus 3y. Now, the question is to differentiate with respect to x. So that means we need to supply d dx to this expression we are given. So then d dx of x plus d dx of 3y. Now, d dx of x is 1 plus d dx of 3y, the normal power rule, you have 3 times 1, because this y using power rule, they simply drop 1 and then subtract 1. So 1 times y raised power 0 is 1. But then because y is assumed to be a differentiable function of x, then you attach dy dx to this number 3. So therefore, this will be the solution to part C. D, we have x, y squared. So the objective is to find derivative with respect to x. So you supply d dx. Now this is a product of two functions. So you remember chain rule, but not chain rule, remember the product rule that we did before. So this, call this one u, call this one v. So this will be given by u prime v plus v prime u. So which means we'll have d dx of x times v, which is y squared, plus d dx of y squared times u, which is x. Now d dx of x is 1, so 1 times y squared will get y squared, plus d dx of y squared. So the thing is that normal power will give us 2y, but then you multiply by x, so 2xy. But because this is y is assumed to be a differentiable function of x, you attach dy dx. So this will be the d dx of this term x y squared. Now, e, we have x cubed plus y cubed. So it is to differentiate with respect to x. So it means supply d dx to this expression of this function. So this means d dx of x power 3 plus d dx of y power 3. Now, using power rule, d dx of x cubed is 3x power 2 plus, using power rule, this will be 3y squared. But because this is y, you attach dy dx because y is assumed to be a differentiable function of x. And then f, we have sine of x y. So this is what we need to do. Supply d dx on this. Now we are going to use chain rule. So here, what you ask yourself, if this is a sine function, when you differentiate sine function, what do you get? The derivative of a sine function is a cos function. So you write cos xy, but then you have to differentiate also this part, x, y. Now, this you use product rule. So let this one to be u, let this one to be v. I remember this will have cos of xy, u prime, so means d dx of x multiplied by v, which is y, plus v prime is d dx of y times u, which is x. So you end up with cos of xy, d dx of x is 1, so we'll have y, plus d dx of y is 1 times dy dx, and then we multiply by x, we get x, then dy dx. So this is what you have, or you can write your answer as y cosine of xy plus x cosine of xy dy dx. So that's what you get. And g, we have e raised power x y squared. So the interest is to find d dx of this function. So what you ask yourself, this is an exponential function. When you differentiate an exponential function, you get exponential function, and then you multiply by chain rule, you need to differentiate the power d dx of x y squared. This is a product of 2, so use product rule. So this to be u, this y squared to be v. So I have e raised power x y squared into u prime d times y squared plus d dx of y squared multiplied by x. So e raised power x y squared, d dx of x is 1, so y squared plus, using power rule, this will be 2y dy dx times x. We get 2xy. Then we are attaching dy dx because y is assumed to be a differentiable function of x. And then lastly, or that you can go further and say be the same as y squared e raised power x y squared plus 2xy e raised power x y squared dy dx. And lastly, tan x y squared. Now the interest is to find d dx, so you supply d dx to this. So you ask yourself, this is a tan function. If you differentiate a tan function, you get sec squared function. And then by chain rule, you have to differentiate this part. That's a product of two functions. So you'll use product rule. So this is u, and then this one is v. So we'll have sec squared xy squared into d dx of x times y squared plus d dx of y squared multiplied by x, which will be sec squared xy squared into d dx of x is 1 times y squared is y squared plus d dx of y squared using power rule is 2y, but you attach dy dx because y is assumed to be defined the function of x, and then multiply by x. So we'll have 2xy dy dx. Then you can expand this and write it as y squared sec squared xy squared plus 2xy sec squared xy squared dy dx. So this will be the solution to that problem. So in the next session, we'll give more examples now on implicit differentiation. Thank you.